Welcome to this lesson on Snell's law. In this video, we'll learn how to predict the exact angle at which light bends when it travels from one medium to another. Snell's law is a fundamental equation in optics that relates the angles of light and the refractive indices of different materials. Before diving into Snell's law, let's understand what refraction is. When light travels from one medium to another, such as from air into water, it changes direction at the boundary between the two materials. This bending of light is called refraction. You've probably seen this effect when a straw appears bent in a glass of water. Every transparent medium has a property called the refractive index, denoted by the letter, and the refractive index measures how much a material slows down light compared to its speed in a vacuum. For example, vacuum has a refractive index of exactly 1.00. Water has a refractive index of approximately 1.33, and glass typically has a refractive index of around 1.50. The higher the refractive index, the more the material slows down light. Now, let's look at the Snell's law equation. It states that n1 times sine of theta 1 equals n2 times sine of theta 2. This elegant equation relates the refractive indices of both media to the angles of the light ray before and after it crosses the boundary. This formula allows us to predict exactly how much light will bend. Let's break down what each variable means in Snell's law. N1 is the refractive index of the first medium, where light is coming from. N2 is the refractive index of the second medium, where light is entering. Theta 1 is the angle of incidence, which is the angle between the incoming light ray and the normal line. And theta 2 is the angle of refraction, which is the angle between the refracted ray and the normal line. Here's a crucial point to remember. All angles in Snell's law are measured from the normal line, which is an imaginary line perpendicular to the surface at the point where light hits. We do not measure angles from the surface itself. This is a common mistake that beginners make, so always remember to measure from the normal. Let's work through an example to see how Snell's law is applied. Suppose light travels from air, with a refractive index of 1.00, into water, with a refractive index of 1.33. The incident angle is 30 degrees. We need to find the refraction angle. Using Snell's law, we write 1.00 times sine of 30 degrees equals 1.33 times sine of theta 2. Since sine of 30 degrees is 0.50, we have 0.50 equals 1.33 times sine of theta 2. Dividing both sides by 1.33 gives us sine of theta 2 equals 0.376. To find theta 2, we take the inverse sine of 0.376, which gives us 22.1 degrees. So the refraction angle is 22.1 degrees. Notice that the light bends toward the normal when entering a denser medium. The angle decreased from 30 degrees to 22.1 degrees because water has a higher refractive index than air.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.